Yo! Hey, yo! How's it going, everybody? Hold on. Why is only my right pod working? Well, it's dead. Why is it dead? Oh well. Okay. My left one's fully charged, but my right one's dead. Yo! How's it going, everybody? Welcome back. Let's get loaded up here. Give me 1 second. One second here, everybody. All right. We should be activated for chat. Yep. Yep. Looks good. All right. How's it going, everybody? Welcome back into my stream. I hope you're having a wonderful day. Man, these days go by quick, let me tell you. Well, today's workday went by slow, but I'm talking about like it seems like I'm right back here in the same spot, just like in like a flash. Like it literally just seems like I was sitting right here. But I had a whole full workday, and even though the workday went by slow, it still seems like I was just right here talking to you guys. So, man, these days are becoming a blur, let me tell you.
Hello.
Hello, Mr. Austin. Hey, yo. Aurora here. Hello, Mahan. Yes, yesterday we started Calc. We started back on our review into Calc 1. Into more specifically Calc 1 with Python. So we are doing the Khan Academy Calculus 1 course. We completed the first 4 segments here, which were pretty easy on limits. So yesterday we learned about limits, or just remembered about limits, right? It's been since I was 19. I'm 26 now, so it's been over 7 years since I last talked about limits. But yeah, so they're a lot easier than I remember them to be now that I'm older and and I learned programming and stuff and taught myself programming. And so coming at it from this approach, it wasn't that hard. It was really easy. I flew through. I didn't get a single answer wrong on the homework things. So we learned just how when we converge from certain directions, whether it be the positive or the negative direction on certain x values, on a function, we report various y values for limitations as we approach those values. And we know if we don't approach those values from from both directions, both positive and negative, that limit does not exist. So that was just a very general overview of what we talked about yesterday. So it was a good chunk taking it down yesterday. So we are going to start the stream off here with, I'm going to pull open a timer. We want a timer for, let's do 20 minutes, or 25 minutes. Let's do 25 minutes. And we'll start that timer. All right, that timer's going here. So we are going to do 25 minutes of some math here. Moving on. All right, let me open up my independent mathematics repository here. And we'll open up our lesson 1, 2. So here we go. We're still on unit 1, lesson 3 here. All right. We're going to do 25 minutes of calculus here. And yeah, creating tables for approximating limits. Let's get on into this. right, here we go.
This video, we're going to try to get a sense of what the limit as x approaches 3 of x to the third minus 3x squared over 5x minus 15 is. And when I say get a
Mahan
sense,
says, do
we're
you
going to
learn
do that
epsilon delta
by
definition of limits, or it's
what values for this expression we get as x gets closer and closer.
Hey, Bizwyan.
Now, one thing that you might want to try out is, well, what happens to this expression when x is equal to 3? Well, then it's going to be 3 to the third power minus 3 times 3 squared over 5 times 3 minus 15. So at x equals 3, this expression is going to be in the numerator. You have 27 minus 27, 0 over 15 minus 15 over 0. So this expression is actually not defined at x equals 3. We get this indeterminate form. We get 0 over 0.
Yeah.
But let's see, even though the expression is not defined, let's see if
Let's
we
start
can
plugging
get
in
a
values
sense
near
of what
there.
the limit might be. And to do that, I'm going to set up
Plug
a table.
in 2, 2.5,
So
2.75.
Set up a table here. And actually, I'm going to set up two tables.
Just basically
So this is
a matrix
x,
for
and this
inputs and
is
outputs.
x to the third minus 3x squared over 5x minus 15.
I like Khan's handwriting.
Actually, I'm going to do that again.
It's pretty like
I'll tell you
soothing.
why in a second. So this is going to be x, and this is x to the third minus 3x squared over 5x minus 15. The reason why I set up two tables, I didn't have to do two
Mr.
tables.
Lambda, how's it going,
I
my
could have done
friend?
one table, but hopefully this will make it a little bit more intuitive. What I'm trying to do is on this left table, let's try out x values that get closer and closer to 3 from the left, from values that are less than 3. So
Yeah.
for example, we could go to
Throw
2.9.
2.9 in
Figure
there.
out what the expression equals when x is 2.9. But then we could try to get even a little bit closer than that. We could go to 2.99. And then we could go even closer than that. We could go to 2.999.
In the other table, he's going to go
so
over
one way to think about it here is,
the limit.
as we try to figure out what this expression equals as we get closer and closer to 3, we're trying to approximate the limit from the left. So limit.
Yeah, you're just plugging. This is easy. You're just plugging in values yourself and just solving for the
Why
function.
do I say the left? Well, if you think about this on a coordinate plane, these are the x values that are
You're
to the
getting
left
bigger.
of 3. But we're getting closer and closer and closer. We're moving to the right, but these are the x values.
Okay, yeah, this
that
is
are
pretty
on the
easy. Let's
long-
keep
or
moving
we're
here.
gonna get
3 point.
to
He
the
does the
left
threes
of
over there.
the
Yep. And so what do you get?
calculator. So basically,
So you get, it converges on, looks like it's, this one's, as you get closer to 3, you're converging on 1.8, 1.8.
than what we're seeing here, I would make the estimate that this looks like it's approaching 1.8.
Yeah, okay, cool.
The function g is defined over the real numbers. This table gives select values of g. What is a reasonable estimate for the limit as x approaches 5 of g of x?
So as the limit approaches 5 for g of x, so we're plugging in values in for x here of 4, 4.99, 4. We're getting closer to 5. And then we are coming closer to the value of 3.7, 3.68. Okay, so it is, we have 3.68. But this yeah, so it wouldn't be 4, it wouldn't be 5. No, it's 5. Right? Because you're converging on that, but then you have definition at 5 at some other point here. So I think it's going to be C.
The reasonable. Once again, it doesn't matter that the value of 5 is 6.37. The limit would be 3.68, or a reasonable estimate for the limit would be 3.
Okay, so the reasonable estimate for the limit is what it converges close to. So it wouldn't be like an estimate of in between, right? Oh, these are what you plug in for the x values, right? Sorry, I read that wrong. I thought the g of x was on the other side. So you're plugging these for the x values, you're converging on, you say 3.68. So I guess you don't estimate a value in between. What's a reasonable estimate? Okay, so you just do the closest one too.
6.8. And this is probably the most tempting distractor here, because if you
Because this is defined here.
What is g of 5? It tells us 6.37.
Yeah.
But the limit does here. So 5, but right at 5,
Yeah, it's defined
our
up there
value is
by
6.37.
something.
I don't know for sure if this is what the graph looks like. Once again, we're just
Okay.
getting some sample points,
Cool.
but this would be a reasonable inference. And so you can see our
All right, limits are a tool for reasoning about function behavior, and tables are a tool for reasoning about limits. One nice thing about tables is that we can get more precise estimates of limits than we'd get by eyeballing graphs. When we use a table to approximate limits, it's important to create in a way that simulates the feeling of getting infinitely close to some desired x value. Imagine we are asked to approximate this limit, where you have this value here. This function is actually undefined at x equals 2 because the denominator equals to 0. But as the limit approaches 2, it still exists. So you just pick. So this is just going over those videos. Okay. So step 3. Look at the table we've created. We have very strong evidence that the limit is 0.25. So as you converge upon 2, 0.25. Yep. But if we're honest with ourselves, we must admit that what we have is only a reasonable approximation. We can't say for sure. Okay, problem 1. 3 students were given a function of f and asked to estimate limit f of x. Each student created a table shown below. So the limit of f of x as x approaches 2. Each table is accurate, but which one is the best approximate of the limit? Okay, so these are inputs for x. And so we're approaching 2. So this one's not really that accurate because these kind of are too, these x values don't really make sense. Well, these ones also don't really make sense too because you're not even evaluating over 2 itself, so it's got to be just b here because we're approaching up from 2 on both sides. Common mistakes when creating tables to estimate limits. Here are several things to watch out for. Assuming the function value is the limit value. No, we've already learned that in the last lesson. Not getting infinitely close, so you need to get values that are very, very close, like in this example here, not like here. And not approaching from both sides, like this one was only approaching from one side. Assuming the left side means negative. Some students may mistakenly believe that when approaching from the left, they mean use negative numbers. No, okay. All right, the function g is defined over the real numbers. This table gives select values of g. So as we input these values of x, looks like we're kind of evaluating over an x input of 5. This is the example from before. So it would be 3.68 from the example. Right, we're converging upon a reasonable approximation. That would be our limit as we approach 5. But at 5, we're defined as some other place, but it's not like I said up here. Common mistakes when estimating limits from tables, confusing the limit value with the function value. Remember that the limit of a function at a certain point isn't necessarily equal to the function's value at that point. For example, in problem 2, g5 equals to 6.37, but the limit as x approaches 5 of gx is about 3.68. Thinking a limit value is always an integer. Some limits are nice, but have integer values or nice fractional values. For example, the limit, our first example is 0.25. Here, the limits are less nice, somewhere around 3.68. Okay, summary questions. A student created a table to help them reason about limit of g of x as x approaches, hopefully that's positive 7, so yes. So at 7 we're undefined, but we're converging on value of, negative 1.925, right? There appears to be an asymptote at x equals 7. What can you reasonably conclude about this? No, it doesn't have to be an asymptote, right? It just can be an undefined point, like a piecewise function. The value of negative 1.925 is a reasonable estimate for the limit of g of x. I like that. Hold on, we'll see. As we approach the... is a reasonable estimate. Okay, so we're tossed between b and d here. The limit doesn't exist between the functions. No, that's not true. We are approaching the same value here as we converge on 7. So as we approach x equals 7, the value of gx indefinitely approaches. Definitely approaches. Well, I mean, it does, but then it's undefined at that point, so we can't necessarily know for sure. So I think it has to be b here. Yes. Not so fast, although it looks like it might be. We can't tell for sure. Yeah, the definitely is what's throwing that one off. All right, the table gives a few values of the function f. The function is increasing everywhere except x equals 5. The limit f of x exists at x equals to 5. Or as x approaches 5, sorry. Um, the function exists increasing everywhere except x equals 5. So at x equals 5, we go down a point. But it's trying to throw you off. It doesn't want you to take 4.8 for the limit. You're converging on 4.9, and then here you're converging on... Interesting for this one. What is a reasonable estimate for the limit as we approach 5? As we approach 5. The function increases everywhere except at x equals 5. So the function would look something. It would just have like it increases and then goes right at 5. Goes back down to 4.8. Interesting. Okay, so then we rule out 4.8, 5.3. It's not going to be 5.6. It's not going to be 4.6. So it would be a 5.3 approximation between 4.9 and 5.6. Interesting. Right, that function, so yeah. Yeah, it's too low. We're converging on a limit in between these values. Nice. People asking questions. Sweet. The function g is defined over the real numbers. This table gives several values of g. Function g is defined over the real numbers. The table gives several values of g. So as we're inputting values, looks like we're approaching. Oh, interesting. So we're putting in. Is the table appropriate for the approximation limit of g? No. Equals to -7. No. I mean, because we need to. This is bigger, so these need to be smaller. The table isn't appropriate. The table doesn't contain x values from both sides. It does contain values coming from not both sides, right? This is trying to do that positive and negative thing. It is this one. Oh, no. It's C? The x values approaching from the right shouldn't be positive. Well, there's not even the right values in general. The table does contain x values larger than x equals to -7. But they seem to approach x equals to 7 instead of x equals to -7. The table doesn't contain. Yeah, it's supposed to go. The table isn't appropriate. Well, yeah, they shouldn't be positive, but these are also the incorrect numbers in general. And so these values aren't going from both sides either, in my opinion. The table doesn't contain x values larger than x equals -7. Yes, it does. Oh, larger. Yeah, it does contain values larger than x equals -7 technically. But they approach x equals 7 instead of x equals -7. Interesting wording on this one, in my opinion. What do you guys think? if this was the 6 if these were the correct values of 6.999, 6.99, 6.9, but they were positive, then I would have definitely selected that one. But yeah, they shouldn't be positive in general, I guess, right? But they can be in terms of but this is regarding this actual limit, so yeah. But it's a interesting one. Okay, cool. Given the function of f, given the function f, and asked to estimate the limit of f of x as x approaches. What is that? Let's see here. Given the function of f and asked to estimate the limit f of x, 3 students. Why does he keep doing that? X approaches 5. 3 students created tables. Okay, so we're approaching 5. So this one's wrong. That one looks better. That one's wrong. All right. The function h is defined over the real numbers. This table gives several values of h. Yeah, that question was kind of silly in my opinion. It kind of had application to both of those, but both of those were kind of strange answer. Oh, I'm gonna get some lemonade. All right. Got me my lemonade. Yeah, strawberry lemonade. Hey, Hysterical Mafia. Yeah, it's a pretty cool course. It's got a lot of like the embedded practice problems and everything, and for free. It's really nice. Okay, the function h is defined. Let's get some tunes going. The function h is defined over the real numbers. This table gives several values of h. So as we plug in values for x, I'm not sure what we're doing here. It doesn't look like anything. This is not an appropriate table, right? The table isn't appropriate. The x values only approach from -6 in one direction. No, the increment values are constant. The table isn't appropriate. The x values only approach -6 from one direction. Yeah, but then they go beyond, right? The table isn't appropriate. The increments in x values are constant. Well, that is also true as well. They increment by -1 each time. these table ones where they give you 2 for each. Good Aunt Mahan. What do you think about this one too? We got another one here. The table isn't appropriate. The x values only approach -6 from one direction. Well, that's true. It does only approach. Well, no, okay, no. So you're approaching -6. No, you are approaching -6 from both directions, from the left and from the right. But it's not appropriate because you're a constant increments, I think, right? No, it's not this one, right? This one is true. It is appropriate for that reason because it does come from the negative and from the positive, even though these are all negative numbers. Yeah. Boom. We learning! Calc easy, baby! Calc easy! All right. Given the function g and asked to estimate the limit of g of x as x approaches -1, 3 students created these tables. All right. So we're approaching -1. So we're going smaller, even smaller. We pass -1 there, and we keep going. So it would be like right here. Okay. Oh, it's extended out. Okay. Each table is accurate, but which one is best for approximating? So then this is -2, -1.1. It approaches -1. It would be this guy here, right? We're converging on -1 here with more precise with more in-depth values. Let's go! A bonus question. Get this question correct to earn proficient in this skill. All right, here we go. We got a bonus question. Bonus question. Bonus question. Question. Bonus question. All right. Keep going. Bonus question. This bonus question is worth $5,000. Welcome to the Cash Cab. All right. Bonus question. The function f is defined over the real numbers. This table gives several values of the function of f. Okay. Is this table appropriate for approximating the limit of function of f of x as x approaches -5? If not, why? Okay. All right. I'm going to open up a poll. Bonus question. A. Is it B? Is it C? Rack them up, baby. Rack up the answers in the poll. Rack up the poll. All right, here we go. I'm going to try it here. All right. So we're converging upon -5 here. Got you. We're getting smaller and smaller. Okay. That's not true. That's not true. I'm going with A, boys. I'm going with A. And A it is. A is what everybody else agrees, and we're all agreeing on A. All right. Nice. Woo! Hey, look at those shoulders. Look at those shoulders. All right. 400 energy points. Let's go. All right. Ready to practice. 4 questions. Let's go. All right. The function g. Spam your answers in chat. We won't do polls, but just spam your answer in chat for each question. The function g is defined over the real numbers. This table gives a few values of g. All right, so we're approaching x as we for this limit of 4. Okay, what is the reasonable estimate for the limit here? Well, all of our values are agreeing on a single value right here in the middle. We're saying Mr. C here is my answer. We'll wrap up this section and we'll move on for today. All right, we got C. Boom. All right, the function g is defined over the real numbers. This table gives a few values of g. Okay, we're coming up to the limit of x equals 5. Interesting. We're not approaching the same limit from both directions. So in my opinion, this limit does not exist. Do we agree? How are we feeling about that? We are not approaching the limit the same value from both directions. Aha! The function g is defined over the real numbers. This table gives select values of g. As we're approaching 5 once again, it's throwing this one at you. It's really trying to trick you with this one. Right? It's really trying to hit this one home. It's asked that question like 3 times now. The function of h is defined over real numbers. This table gives a few values of h. All right, so we're approaching -7. So this is a good table, and we're converging on a value here. Looks to be -3 in my opinion. Or wait. Oh, so this is just a parabola then. Right? And so it's touching -3. Woo! Oh, look at those shoulders! Woo! Oh, whoa. Nice. That is what I'm talking about. All right, we got one more video and then one more set of practice problems, and we'll be done with calc for today.
The function f is defined over the real numbers. This table gives select values of f. We have our table here for these x values. It gives the corresponding f of x. What is a reasonable estimate for the limit of f of x as x approaches 1 from the left? So pause this video.
So as x approaches 1 from the left, so we're approaching 1 here from the left as we're getting bigger. So reasonable estimate for this limit, in my opinion, would be 2. Aha! Yep. Now how about this guy? This function is defined over real numbers. This table gives select values of f. So we're trying to come up to -2 from the left. So some smaller values here. We're getting larger. So we're converging what looks to be upon. So as x approaches -2, this is coming up to -500. This then jumps all the way up to -4. So does this not exist? Oh, from the left. So sorry, not total. So from the left, it would be we're coming up on. Well, this is really starting to jump. -500, I guess, somewhere around there. Is that what it? Oh, it's unbounded. Let's see what you have to say about this one.
These two negative signs. This first negative sign tells us we're approaching -2. We want to say what happens when we're approaching -2, and we're going to approach once again from the left. So lucky for us, they have values of x that are approaching -2 from the left. So this is x approaches -2 from the left. And so that is happening right over here. So that's these values. So notice, this is -2.05, then we get even closer, -2.01, then we get even closer, -2.002. And these are from the left because these are values less than -2, but they're getting closer and closer to -2. And so let's see. When we're a little bit further, f of x is -20. We get a little bit closer, it's -100. We get even a little bit closer, it goes to -500. So it looks...
so it's showing like asymptotic behavior. So it's unbounded. Got you. So because it's showing such rapid like exponential growth for these values, it's showing asymptotic behavior, so it's unbounded.
From the left does not exist. Choice negative. And so technically, it looks like this is, I would write this is unbounded. Unbounded. And so if this was a multiple choice question, and technically you would say it's negative right over here. And remember, when you're looking at as x is approaching, in this case, -2 from the right. So as we're getting closer and closer to -2 from values, or just by sampling some points, but these would this would be a reasonable estimate, and we've seen that.
Gotcha. Interesting. All right, 4 questions here. 4 questions. The function f is defined over real numbers. This table gives select values of f, right? So as we approach x of -1 from the positive direction, so we're coming up to -1 from the right. Hold on, so it's hard to read this way. Okay, so we have -1 here. These values are getting larger, so we're approaching from the right here. It looks like we're converging on a limit of 2 from the right. Woo! The function g is defined over the real numbers. This table gives select values of g. So g of x, we're approaching 0 from the right. So we're approaching from this direction, from the bottom up, and looks like it's approaching it's unbounded. Woo! The function f is defined over the real numbers. This table gives select values of f. So we're approaching 1 from the left side, right? And so as we approach this value of 1, what's happening to our outputs? It looks like we're converging on a value of 2 for this one again. Woo! The function f is defined over the real numbers. This table gives select values of f, of the function f. All right, so what is a reasonable estimate for limit f of x as x approaches -2 from the left? So as we approach -2 from the left, looks like we're unbounded again here. Woo! Hey! Oh, quiz 1 is up next. Should we save quiz 1 for tomorrow, or should we bang out quiz 1 today? What do you guys think? Quiz 1 today or quiz 1 tomorrow? And have it be our tomorrow's math segment. Do 3 days in a row on limits to solidify the knowledge and then move on to the next after that quiz? Or bang it out today? What's up, Twillick? How's it going, my guy? Thanks for jumping in here. What is the zap? The zap is the quiz. It's just the quiz. Quiz today? Alright. Alright, we'll do quiz. Quiz time! 6 questions, 6 to 12 minutes. We'll see if we need 6 to 12 minutes on this. All right, here we go. Focus up, Mike. All right, spam your answers in chat if you're following along with me. Spam it up. Leave a like and sub here if you're new. Thank you guys so much for being here. We're teaching ourselves calc from scratch. Woo! This function g is defined over the real numbers except at x equals to 2. This table gives select values of g. All right. So as we approach, what is the limit of x as we approach 2 from the right? So we're approaching 2 from the right. So we're getting smaller towards 2, and we're converging on a value of, looks to be 7 in my opinion, even though that is undefined. So C. Everybody saying C? Mahan says C. Boom. Next question. The function h is defined for all real numbers. All right, we're getting graphs now again. What is the reasonable estimate for the limit of h as x approaches -2? Oh, I hate when it does this little thing. Okay, x approaches -2. So the overarching function. We're converging on 2 different points. This limit does not exist. I'm going to say D here. I'm going to say D. Big D on this one. All right. What? I have no idea what you mean. We're trying to learn math here. What the hell? All right. Next up, given the function h and asked to estimate the limit x equals as x approaches -8. 3 students created these tables. Oh, these ones suck. Okay, so we're approaching, and this one doesn't even cover the value of 8. So that one's not right. That one sucks. It's going to be C on this one. What do you guys think? I'm going to say C. Letter A doesn't even go over the value of -8. B just sucks in general. And C is correct. Woo! Moving on. The function h is defined over the real numbers. This table gives a few values of h. You say my reasoning's wrong for the first one? I don't know if we can go back. It didn't even go over the value of -8. It only approached from one side. So you couldn't know for sure. The function of h is defined over the real numbers. This table gives a few values of h. Alright, we're approaching a -3. Mr. David, what's going on, my guy? Mr. David! Well, it was asking for the overall function and it didn't give a value from the other direction. Which is what I meant by it didn't converge on the value of 8 from both sides. Alright, -3. We're coming up here for the overall function. This one does not exist. Right, this is coming up on 5, this is coming up on 1. So these are converging on 2 separate places. It's not coming from any direction. Doesn't exist. The function g is defined over the real numbers. This table gives a few values of g. Alright, we're approaching -2, and we're coming up here on a limit of, looks to me, it's saying 8. It says 8. Oh, it's a parabola. Okay. Yeah. So it comes down, kisses 8, and then turns back up. Consider graphs A, B, and C. Which graphs agree with this statement? Limit, equals to 3 as x approaches -2. As x approaches -2, no. It's going to be C here. Letter C. I'm going to say C. We're coming up on from the left to 3, coming up on to the right to 3 when we approach -2. 100% on our first quiz! Woo! Yes, that's what I'm talking about. Leave a like on that. Banging through cow. Give me a simple def for approximating limits with tables. And we got another zap. What is this? Oh, if I press next, I think it'll clear that out. So if I go back to what a hot streak, a 1 week hot streak. So if I click here, oh, it just doesn't gray it out. Weird. Sweet. Approximating limits with tables means finding a value of a function that gets closer to the x input, gets closer to a certain number by plugging in x values near that number into a table and observing the trend in the outputs. Yeah, so let me grab a quick thing of notes for this one quick. One sec. I just want to quote what they say. So we can say use a input output table to evaluate the limit as x approaches a certain value for the function. Choose inputs specifically close to the desired x value. All right, and then I'll copy this and we'll throw this guy in here and say revise my def. I know, once we start learning about having to plug in these various, like, all I remember from when I was learning Calc 1 back in the day, back in 2019, I remember very specifically going to the Portland State Library and sitting up on the top floor with a bunch of crackheads that were out up there just hanging out. Because it was like anyone could go into the library there. So a bunch of like kind of crackheads were in there. And I remember just teaching myself and trying to remember the various like stuff that you plug in. Like you have to plug in a bunch of like equal things or something. Y'all forget I've done this once before. I got an A in Calc once before. So this ain't my first rodeo. It's just been so long, we're going through it again here. What was that? Use an input-output table to estimate the limit of a function x that approaches a specific value by choosing input values that are very close to the target x. And we'll say observe function. Okay, so I'm gonna take a screen cap of this limit here. And then I'm going to take a screen cap of this table for my notes for you guys. All right, cool. Nice. All right, cool. So that brought us to our first quiz. So we're still on Unit 1 here, which is limits and continuity. So we have limits and combined functions, sums and differences, products and quotients, composite functions, direct substitution, limits that don't exist, limits of trigonometric functions, limits of piecewise functions, and then another quiz. So we'll keep going here at the beginning of our streams with some calculus studying. Did more than 20 minutes, so that's for sure. Y'all want to do that, the quiz. I was watching this video in traffic today, not watching, listening to it. Have you guys watched this at all?
Is charged.
Advanced Algorithms Comp Sci 224. He's talking about Van Ende, is it Endeboas? Trees and fusion trees. He hasn't gotten into fusion trees yet.
Exactly once.
But he's talking about like the time complexity of these advanced algorithms, and they were kind of going over my head with like the log W with the word, like the max, is it the max word theorem or something like, I can't remember. I didn't remember. I haven't learned about that yet. But it was interesting to kind of watch. I listened to about an hour of it. That's how long my commute is. All right. Cool. So let's go ahead and push this up. Next status on branch main. Oh, shoot. Oh, yeah, man, okay. What did we finish? We finished Unit 1, Lesson 3, and Quiz 1. Sweet. You guys want access to my calculus notes? You can get them on my GitHub. They are there for you guys. All right, my fellow suckers. How's it going? What should we do now? Should we work on our project? I think so. Okay. I'm gonna put this like in the background while we work on this. I kind of want this to like play in the background or something for ADHD guys. But I don't know how to do that. Oh well. Can I pop out this window? No. All right. That's fine. Whatever. Okay.
Alright, we're in South Central Iowa right now. Missouri is right over my shoulder. I want to talk about how I used acres before.
All right. Let's get back into the project here. So we're on our web scraper here, where we can put in various compound IDs and get back some extracted data for some JSON that we are pulling via API from pubchem.com. So we need to write some regular expression to figure out what to do with this stuff. All right. So let's type in like benzoic acid. What do we get? Okay, we get max absorption alcohol. So this is what I want to look for. a lot of these have this max absorption alcohol in them. So I think that's gonna be the first thing that we're gonna try to regex. Whoa, my chair, come on, scoot out. Jesus Christ. All right, lift up this guy. Okay, there we go. All right, let's see here. So we want to write some regex to extract out these values, right? So here we go. Let's do this. Okay, import regex as read. Okay, so if I remember right, we have to pass in our strings. Let's pull up the, can you give me a review of the regex docs? Regex expression is a sequence of characters that form a special pattern used to match strings and part of strings. We know that. Okay, here we go. Any character except a new line, starting string, ending string, one or more of the previous character, one or more of the previous character, 0 or more, one or more, 1 or 0, exact repetitions, match any of the one characters, match any character not in brackets. Okay. So let's first match this. Okay, let's think here. What's the song I'm playing? It's just, honestly, I think it's some AI music. This Luna Lounge, I think he just makes AI music. And so, I'm not sure what the, copyright rules with AI music. So, it's kind of interesting. And I haven't had any, and I believe he allows you to, like, all these AI channels, they don't come after you or anything from what I've experienced, from what I've seen so far, so just chilling. All right, here we go. So we want to have a pattern. All right, and we want to set this pattern equal to popping it ahead. We want to have this pattern equal to a raw string, and we want it to have max absorption, right? Alcohol. Okay. Going to go like this. It's going to have some amount of some integers. Do I have to escape these? So then we have alcohol, and we need to have any digit any digit Hey Jacob, how's it going, dude? Yeah, awesome. How's CS50 going for you, my guy? So any digit, and then So this is going to be any digit. Now, how many times we want to do? Match any character if it's in bracket. Exactly and repetitions. One or more of the previous character. So one or more of this value. So we're trying to extract this here. So we're going to take integers, one or more of them. So some white space exactly one time. So \s one time. A number of digits, a white space one time, and then we want to have some alpha character. So it's going to be 2 times. So any character 2 times. Okay, so this is our pattern. Okay. We're going to also extract out this. So we're going to take some white space. One time. A \parenthesis. And inside of our parentheses, we're going to have log e equals this any character, so a white space character one time, any value and then any value one or more of them, and then a closing parenthesis. Yeah, Sean, this is my project. This is my SpectroSim project. We're working on, so we wrote a couple of functions over this past weekend to evaluate and actually extract out some API information that we got via JSON. And so we parsed a big, huge thing of JSON, and we spent a couple hours kind of going through all the different sections of this JSON and finding which headings we wanted and whatnot, and where they were located. And so we were able to get spectral information, get UV spectra information from this, and then we have a CID we get of the compound, we get data of that CID, we get the spectral information from that data, and then we get the UV spectral information from that spectral information. It's just heavily nested in that JSON API. And so then we're getting the absorptions, right? The individual absorptions for these molecules or these compounds, and we're trying to use regular expression to extract out this guy right here automatically, because we're running and we're making these spectroscopy simulations based off of a Gaussian, what's it freaking called? A distribution, and then a lambda max, or a wavelength, maximum wavelength for this absorption spectroscopy. So I have a degree in human biology and chemistry, I worked for a few years as a chemistry lab instructor while in college. I worked as an undergraduate teaching fellow for chemistry as well. So even though I graduated in kind of biology, I mainly focused on the chemistry side of things, intertwining that into biology and biochem stuff. And so I really am into all that, and I work as a chemist. So I work for a biotech company as a formulation chemist. Okay. Hey, Scrally Bones. I like that name. Scrally Bones. That's a cool name. A lot in place of MATLAB as an electrical engineering student. Yeah, dude, that's awesome. That's what I'm kind of doing right now through our independent study of calculus. I'm going to be using Python as my calculator to solve these problems and do whatnot. Use like arrays to loop over them and make these tables or whatever if I need to. Yeah, that'd be cool. Okay, so how does this look? Okay, so let's go to the almighty orb here. Okay, hold on. So actually, let's see if we can this work first. So regular expression has a couple of methods. Okay, we're gonna say for so what if we instead say this here, for value in values, we're going to re.search pattern and on the value, and then re.search. Scan through the string looking for, what does this return? A match, which is a string, a list of strings, or none. It's returning a match object or none. Okay, so then if I say match equals to this, and say match dot what if I just print the match? Okay, didn't get it. Shoot. No. So what if we say any white space one time here? And what if we say any white space one time here? And then here, any white space one time. No. Okay. So let's think here. So what if I comment out this pattern? Let's just start smaller. Let's say that the pattern is equal to a raw string of max absorption. Let's see if we can get that out of it. Yes, we do get that. Okay, so now let's try to keep expanding this until we fail, right? I think that's a good way to go about it. White space one time. With a literal parenthesis, alcohol, literal parenthesis. Ooh. Okay, do we get a match now? No. So maybe it's these guys. Do I need to escape these twice? How to add in a pattern. No, a literal verb. A literal parentheses. Use backslashes. So let's get rid of this guy. Okay, so it's this word crap. Or this white space. Okay, so that works then. Now let's put this. Let's give this. Here. So this is, what is S? One time. White space. One time. So we don't want to give white space. Oh, it's my cat. That's that noise. Hey, Frost, Robert Frost. How's it going, dude? And then white space. Okay, let's see if we get this. Okay, we got it. Max absorption alcohol 227. Okay, so now we're gonna give space here, space, a word. So we're gonna give some white space and a word 2 times. So get the nanometer. Yes. Woo! We're doing it! We're doing it, boys! Just take it little chunk by chunk. Try to just capture each little letter by letter, and then it kind of works that way. All right, next we're gonna need I did a word 1 time. Why did I do a word 1 time? Let me print the value here. So I did a white space. Okay, so white space. Then you're going to do a literal parenthesis. E equals, or log E equals to some any dot plus. Let's try to, do we get it now? Let's see. Let's remove this print here. Yes. What's it doing with this? I don't know what Regex 101 is. I'm just using the RE pattern, the RE import here. That's what I was taught. Max absorption alcohol, Cool, so now we're getting that, but we're getting one beyond this. If I get rid of this, run that. How do I end the pattern? So if I do this, I'll get everything. I got all of this except until the white space. So what happens if I just get rid of this? I just take the log, okay. Now I'll take the E equals and the space. Gotcha. Now I'll put in any character one or more times. And then do I end the string here with a $sign? So the thing is, I don't really want this guy here, this space at the end with this semicolon. I want it to just end on the final parenthesis as such, but I'm getting this extra characters here. Hey, Skur TV. Oh, gotcha. So, yeah, we can use a script to do it, or a tool to do it once we actually learn more about Regex. I don't want to learn more about it and actually use it myself before I trust a tool to do it. So at least I know if I use a tool, then I know it's outputting the correct things because I have experience with it. Okay, so I'm going to take my pattern here. I am going to go to the orb here and say, all right, I wrote my pattern, but I want it to end right on the final parenthesis, but it's going slightly beyond until the next white space. Use non-greedy matching with plus. Dot plus tells her to stop at the first closing parenthesis after log E rather than. What? So this is saying. Oh, so explicitly put a question mark here. So what does the question mark do? Let's see. The question mark. One or more of the previous character. What? That'll do. Oh, I guess that does take care of that. Why does it do that? Here's your corrected pattern. The dot plus tells us to stop at the first closing parenthesis after log E equals rather than the last one. Okay, so now what we're going to want to do, now we have this pattern here for finding these expressions. So this gives me an object. How can you interact with a search match object? Group 0 or just match index 0. Group them all as tuples. Okay, so you can get your groups out of here if you have them. Okay. So then can I say so match, print match. So if I print match, just index of 0, none type. Oh, okay, so if I come out of here, so what, do I need to set match out front? Match is equals to a re.match object, and then set this to override on matches. This returns a match. So what if I say, I'll go like this, I'll say if match, right, match index 0 dot, or we'll append this, we'll say found match is equal to match index 0, and then we can just say found match out front here is equal to none. And so now if we get this, so this gives us found match. Now if we print the found match at the end of the loop, we'll get our match. Perfect. Woo! Look at us, we know Python. Nice. Oh, Mr. Tim. Sorry, dude. You write your regex string and it breaks it down for you, and you can put content in it and displays what the regex would grab from it. It doesn't auto-generate. Is greedy, meaning it will find the last occurrence rather than the first in your string. So the question mark is greedy, meaning it will find the last occurrence. So how does that manipulate this then in context? So what we had before is we removed this and we were getting a little bit of characters after until we hit a white space. So by putting this question mark here, does this interact with the dot plus or with the parenthesis? Good evening, Mike. Taco Tuesday. Yeah. Anybody got some Taco Bell today? Dude, it's only Tuesday. It feels like it's like Thursday, man. Golly. Rough. Okay. Max. Add regex for max absorption for quote JSON parse. Alright. Manon, how's it going, dude? Mike needs vacation. You're lucky you're in the West. You get all the national parks. The dot plus also match 0 is your entire match, not the regex captured groups. I need to remove the backslash. But if I remove the backslash, it's not a group though, it's a literal parenthesis. So that's why I have that. Well, match index 0 is giving me the individual match. It's right? See? If the individual match this is an object returned to me. By indexing into it, like it said, I can extract out, it's a list basically of, it has a support for the, for get item. Under get item, I believe is the, right, because I am printing out found match and it is a string. If I print out type of found match, it'll show string. Okay, moving on. So now that we have found match, we're going to return the found match. Okay, so now let's wrap this in a function. So this is going to be def what should I make this? Dev spectral, I don't even know, ABS spectre. Spectro regex. I don't even know. Given some pattern, or given some so my get UV, I'm appending to a list and returning a list. Okay, and so then my values of the list. This is a list. So we're gonna say you're gonna put in here strings in the form of a list, and you're gonna return. What shall we return? We're going to return a string. So now can I do some groupings on these actually? Let's see here. So I want to group. So I'll say extract alcohol absorption. Extract alcohol ABS spectra. Extract alcohol absorption spectro, right? So then this is, so can we, what we can do here is we might be able to just group, right? This is the reagent, is group 1. So we'll make a comment here. Group 1 is the solvent, right, which is alcohol. We have group 2, which is this guy, which is going to be the lambda max in nanometers. Ooh. Group 3 is going to be this guy here. So I'm going to comment out this for now. I'm going to say this is match. I'm going to say so we got a match. Found match. And then found match is a string. So if I print match.groups, but I need to say first, I need to say if match print match.groups. So now what I'll do is I will just call extract alcohol spectro on the values and see what happens here. Built-in methods group object, okay. So how do you use that? How to use match.group/groups in regex. Let's get caught up on chats. Hello, dudes. Hey, AZ, what's going on, my friend? Welcome back in, dude. If you guys are here, leave a like. I appreciate you. Hey, we hit 2150. Thank you guys so much for 2150. Woo! Oh, that would explain it. Alcohol 227 4.06. So this is the epsilon. Oh, let's go! Woo! Okay, so I'm going to put my group 1 inside of this parenthesis, and so now I get alcohol just as a string. Yes! Isn't this cool? There's only one pattern. That's why I'm using the match or the search function. Because you're given, so I'll show you. I'll show you if I print values here. Right? You're given a list of strings. Right. Right. So what is this Sattler ref number 779 IR Prism 1160 IR grading? Not sure. So then this string is just a separate one. So that's why I'm just matching the singular string. Someone upsubbed, yeah. Brutal. Brutal. Hey, we back. Thanks, some programmer. Appreciate you. Quick hints. Add the parenthesis. I love that. List any. You should be accepting list stir. Oh, so you want me to say list stir? Is that the proper connotation for, or is that the proper syntax for type hints? I don't really use them that much. I'm trying to get better at it though. Thank you guys for being here. My name is Michael. I'm 26. I graduated college back in 2021. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I have a degree in human biology and a minor in chemistry. I really appreciate you guys being here. We're making a spectroscopy simulator right now. We're just extracting out some data from an API request we wrote earlier with the requests module for our overarching project of plotting using Matplotlib spectroscopy, absorption spectroscopy curves using Gaussian distribution. Pretty cool. Pretty cool. What's your input on the regex? String listers. Okay, so now let's, instead of printing back a list of strings, let's return a dictionary. Right, let's return a dictionary. So let's say found. Oh, come on. Match is equal to and then what we'll put in here is we'll say this is going to be the solvent, and that's going to have a value of solvent so if it's not defined, I can't just pre-establish it. Okay, so what I'll do is I'll just create a dictionary. And then what we'll do is we'll just append the groups dynamically inside here. So we'll go found match is index of we'll say solvent is equal to match dot group. We want group number 1 and found match not solvent, and then we'll do number 2, number 3 here. We'll match not solvent, but we'll say this is going to be lambda max, and then this is going to be epsilon. But the thing is we need to convert epsilon. So epsilon is equal to match dot group 3, and then what we're going to say is we'll put epsilon here. And then we'll need to convert epsilon. So this is a log base, a log E. So we need to do epsilon is equal to match group 3. Is it 10 to the power of match group 3? And then found match epsilon, and then we can return found match here. Right, because our epsilon is given to us in log base 10, right? And so we need to raise the value to the power of base 10. And so then hey Hugo, thanks for coming in, dude. Hey, Carlos, what's going on? Have you finished Python Crash Course, Carlos? No, like the raw data. I'm just curious what you're regexing on. I also work in environmental monitoring. Formulations work is sick. Awesome, dude. Yeah, sorry. I'm regexing on. So what we did is I'll go back. So we have a get CID function. And so we're going to put in a compound name string into this and request via the PubChem API, Pug REST API, for that compound's name's CID. Once we get that value back, we query the REST Pug view API for a JSON view of all of the information for this compound ID. We then access the record and section of that and return that value, just to condense it down a little bit. We then go to get the spectral information on that JSON data. So we say for every section in the data, right? If the section TOC heading is equal to this, we're going to return that section. And then within that, right, we're just keep chaining these down. Within that spectral information, we're going to say for section in there, if the section TOC equals to UV spectra, then we do some conditionals for if it has an information section appropriate to it. And then, right, we spent about a couple hours kind of reading over the JSON and extracting out the different sections out of it. It took us a couple hours to do. It was a pretty big document. So currently, it's not the best search algorithm, I guess. Like, you guys think we could implement some sort of binary search on this JSON rather than just looping over? Like, the thing is, we don't have like less than, or we're not talking about data points, right? So like, it's not like a sorted array or anything. So it's not integer values. It's interesting. Because if you think about it, if I open up this JSON, how is my command F, how is that able to find max absorption or the word max so fast? Whereas my loop here, right? Whereas my loop here, if it works, because I don't have the whatever set up. Oh. It's a string, I forgot. It's a string! Invalid literal for int with base 10 4.06. Oh, it's a float, sorry. It's a float! It's a float! And then this might be a float as well. It's a float! There we go. So now I'm not going to turn found match. Remove this. Let me print found here. All right, solvent alcohol, lambda max is 227, epsilon is this. So can I round this epsilon off to Python docs. Anybody remember how to round floats? Not decimal. Using Regex, you can just loop through the entire JSON string to turn the string into a dict. I'm not turning the string into a dict at all. or I guess it's going here, response.json. Right. I use response.json. It stays as a JSON object. That's really cool. You're having to parse content as JSON objects, which is deserializing things you. You're having to parse content. Which is an object which is deserialized, and then you iterate over everything. Well, whatever. Okay, let's try to figure out how we round floats here. I forgot. So we could use a round function, or we have the round function, I know that, but is there a way we could format it? Can I just do this? Is it 2f? Oh no, it's 0.2f for the decimal. Okay, so that does convert it to a... So let's move the float outside the f string. That should take care of it. No! Format code F for object type of stir. Do I not need that? Huh. Interesting. Oh, that's right. Okay, I get what you're saying. I could use the regex on the entire thing rather than breaking it down by section. I wonder, is that any faster than... Well, let's try it. We could try it. So we say... So what would your input have to be here then? A JSON, a dictionary? We could try it. Maybe we don't even have to do a bunch. We wouldn't have to break this down then, right? We could just get the CID, get data, and parse on that, and then we could avoid these two for loops. Oh, gotcha. Whereas searching with Control F, it knows the file size, allocates memory from there. Okay, so the JSON, it's just one giant string. Okay. Okay, let's see here really quick. Let's try to fix this. Why isn't this working? So, unknown format code, epsilon. Oh, I need to convert it to a... What? Okay, whatever. Let me just use the round function. Whatever. Ah, the round makes it an integer as well. gosh. Okay, so if you round, can you round a string, or do you have to be of type int? How can I just round the float? I feel like this is basic. So yeah, it's a stir. I can't do it, but I don't want to convert this to a integer because I don't want to cut off its decimals. I want to round the float, but I can't round the float. At most one argument. I got 2. Oh, that's applied to the float, my bad. Now if you just round the float. Oh no, so now we need to put the round here and do this, there. Woo! All right, we got it. Nice. All right, now we're getting some good round in there. Woo! Yeah, no, I appreciate you, Civil. Thank you so much. Anything and everything. Good luck on your journey teaching myself Java with bro code tutorial on YouTube. Keep it up. I'm sure you'll get down. Practice makes perfect. Nice, dude. Yeah, good on you. I watched the bro code React video. I watched about 2 hours, about half of it. And I was able to, with half of it, I was able to build my portfolio site with React. So it was fun. Definitely not Mr. Tim. It's a work night. It's a school night, Tim. When you do the JSON functions, creating representation of it in Python, process memory has to interpret the syntax of JSON and dynamic. That's basically runtime. Oh, gotcha. So should we use the Regex instead to parse over the So I wonder here, let's try this. Let me remove, I don't know, can I actually, let's say this. Let's go, I'm gonna take this pattern, we're gonna bring it down here. Let's go, so our stuff, our JSON data is here. So let's go data, or re.search for this pattern on data. Okay. Let's then found is equal to this, and then let's print found. Let's see if we get that object and is any faster. Expected string or bytes like object not got list. Okay, so it's a list. Okay, let's. Okay, so my original request, I'm getting the CID and I'm returning that. And then I'm requesting for the response in JSON. And I'm returning the value Hey, Gina. Cracking me up. So how should we set this up if we're trying to parse on the actual JSON string itself? Is this what we're wanting to parse on? Takes in a JSON object. Compound data. I've already done it, Hugo. I've already extracted. I spent like 2.5, 3 hours extracting it out myself with all these functions. But now we're just trying to go over a possible optimization. So we want to jump on the data. Okay, let's call. Let's dump the data and then print found. Okay, hold on. We don't want to print this. I think it found it. Boom. Okay. So, should we time it? Should we see what's faster? 3 separate functions or 1 overarching function? Should we time it? Should we import timer and see which one's faster? What do you guys think? Well, that would have saved, like you said, that would have saved me some time. I went CID and then I got the spectral information. I had to figure out which heading was. I had to go through and figure out where it was. And then I had to figure out which heading pertained to this one. And then get the values. But all I needed was just this right here. Just 3 lines replaces all of this. Oh boy. So let's think here. So then if we can just say, let's just say get data via a CID, right, which is an int. Oh no, we have that. Get data via CID here. So let's call, we have CID, we have data, which is get data. So we're dumping data. So what if I just return rather, I say the timer. Okay, well, we want to time it, right? Do we want to time how fast it is compared? So this section here versus all of that. Yeah, it's a big JSON, but from all the compounds I've looked up, there's only one of these strings exactly in this format. Like, it's pretty universal across their system. At least this one specific instance of like this experiment. they have different experiments listed as well, but most of them have this one. So do we need to import timer or time? And then we're gonna say, extract this via the values, and then we're gonna print with this guy, and we're gonna say, so here we're gonna go what time dot is it start? How do you start a timer? Nah, dude, I'm not gonna ditch Python and start over. That defeats the whole purpose of the project. It's not meant to be the most reinventive project ever here. We're just learning. All right. So how do we start a timer? How to time functions. Time dot start equals time dot time, end equals time dot time. Right. Time and verb. Okay, I got you. So we have start equals time dot start or time dot time. We're gonna have end equals time dot time, and then we're going to print start or end and start. Okay, so then let's cop out that and let's see how long this takes. All right, here we go. Place your bets now, boys. All right, that took a little less than a second. Little less than a second. I'm throwing that. All right, 0.81. Okay, now let's put our start. Here. And we'll take this, put that here, and then I'm going to copy out. We need to get the CID. We're going to copy out these two. And then we're going to bring these guys back. Okay, 0.81. Call dot text. All right, here we go. Way faster. Look at that. All right, thanks for that tip, some programmer. Improved our algorithm here like 1,000-fold. All right. So that just completely torches all of this, which is fine. It is what it is. We live and we learn. We'll say, but I want to delete it. I want to kind of keep it just for fun. We'll say, I'll just come here and make like a doc string. We'll say refactored into single regex pattern scan across response across API response. Okay, so then what we can do here is let's go, if I return dot text here, and then return just that. How long does that take? So this took 0.005, right? So let's remove this let's change this to .text rather. So now we don't even convert to JSON, we revert immediately back. By not converting to JSON, we can save that pass. So let's try this now. Invalid search response. Okay, so it didn't like the .text. Oh yeah, I just need to search pattern on what is it? Data? Yeah. All right, now let's try it. So 0.00548898 is the time to beat. Survey says. Right. Expected string or bytes-like object got none type. Uh-oh. So let's see what happens if we print data here. None. Oh, .text. Gotcha. It's just a attribute. Okay. We were getting none. Okay. All right. This is 0.0003. So I think that's faster. Our last one was 0.005. So we improved this one again. 0.0009. All right, so we improved this by, I can't remember. Anybody remember the last number? What music is this? It's the Luna Lounge. The Luna Lounge. I think it's just AI. Anybody remember the last numbers? We have, so these are taking about less than 1,000th of a second. That one took a little bit longer. So it just depends, I guess, slightly. But it's definitely faster. Okay, cool. So I'm gonna take these and I'm gonna move them down to the bottom. Let's get those out of the way. I want to keep them just to have on hand, just in case, so I can reference, but we'll move them out the way. Okay, so we can take out the time. Tim's jiving over here. I can just see Tim in his room just grooving. Okay, so we have the CID. We need to keep that. We're returning text. So let's just clean this up. Return that. So we don't even need this key error anymore. So we have this function write data. I have this kind of auxiliary function. Honestly, I don't even need this anymore. I was just using this to visualize the APIs and see what they look like. I'll keep it just at the bottom. Okay, so we don't need that. We don't need this. Don't need this. Okay, so now we need to edit this here. So this is going to just pass in a string, right, in the form of stir. Given this pattern, matches found, we're going to say, we don't need to loop here. We'll bring this back, bring that in. Match is equal to re.search. Pattern on the string. If match, we're going to do these groups. How can I do, does re.search give you groups? Yes, does give you access to groups in the patterns with parentheses. Okay, good. So we'll still return the match, and then we can remove that. Ooh, we'll do that. Okay. All right, and then let's see here. We are going to print out, call this on data. I'll call this data string. Right, and so we can remove this. Now let's see here. Woo! Yes! Way easier. 2160, gentlemen. Let's rack it up. Rack it up. 2160. Subtrain. Yeah, so much simpler and faster. Okay, cool. And especially if we're going to be doing these queries on a back-end server, we want it to be as fast as possible. So I'm returning a dict because what I'm going to do is, rather than, so I'm going to have two steps to the, so on my front end, when I build the front end, right, when you run these compounds, when someone queries for a compound using the API, what I'm going to do is I'm going to save it locally. I'm going to create that reference dictionary object and save it locally into JSON, and then extract it out if another user queries for that whatever, right? So that way I don't have to keep requesting the API on like the same thing over and over again. I can just save previous searches locally, and then, you know, maybe clear them out after some certain periods of time. But I'll have my search first check in my local database or remote database for the information, and if it's not there, then go get it and extract it out. How does that sound? Right? Okay, so we have a web scraper here. We're returning a found match here. So this is giving a string. Alcohol is the solvent, but the overall benzoic acid. Okay, this is what I'm going to do. I'm going to have my I want to retain this input. I need to retain whatever they have so I can reference it in this data object, this match found, so I can have it saved locally. Right, so what I think I'm going to do is have my CID, get CID function, return a tuple, right, where we're going to have return name and the CID, right? And then what I'll do is get data vi CID we're going to put in CID index of 1 here. And then, right, and then this gives us returns response text. I'm going to say a tuple again of CID index 0, CID index 1, and the response text. Now you're going to accept a tuple or a string here, right? So when I call this, I'm going to call it on data string or data tuple index of 2. And now my data, this becomes data tuple, get data via CID. So we get CID, this is the CID. We then pass this and get a data tuple. So then I can return a found match. No, I want to pass in the entire tuple. So I'll say data tuple here. The tuple, and then, right, so I'll say string is equal to data tuple index of 2, right? Okay, so I need to add in some, obviously, some error checking to make sure that you're getting and able to access and index into these values and make them type checking, but I'll do that later. It's getting late. So, right, what we're doing is we're passing in benzoic acid string into CID. This get CID function is returning the name as well as the CID int. So what we're going to do is we're going to get data via off that CID returned tuple. So this is going to be a tuple here. And this is going to return a tuple again. Right? And then we return this tuple here. We then say, so that's this tuple here. We go into this tuple, and we're going to return a dictionary here. And we're going to make found match index name is equal to data tuple index of 0. And then we'll do this one more time, data index 1 for the CID. Okay, let's try it out now. Aha! Woo! Let's go! Okay, I'm gonna go like this. I'm gonna go here really quick. We're gonna make the name. Return that dot lower. Yeah, right. Okay, so what we'll do, returns a tuple of name CID of the name and CID of the compound name provided. Compound name provided. Okay, cool. So given the name of a compound, search PubChem via PugRest API for the SID for the compound within an online database. The PugRest API returns a response object of minimal data related to a compound like its CID. Returns a tuple named tuple name and CID of the name stir and the CID of the compound name provided. So then in get data here, we'll write a quick doc string for given the we'll call this the CID tuple. Given the tuple returned by get CID function, we'll say search the PugView PubChem via the PugView REST API. For the compound data. It's going to be CID or index of one. Given the tuple returned by getCID, search PubChem via the PugView REST API for the compound data pertaining to the CID within the tuple CI within the tuple. All right. So then this will returns a tuple of compound name, compound CID, and compound data. This is a text. Nice. All right. Sweet. Don't need that. So we call get CID. We don't need this pattern here. Let's take this down. there. And clean that up. Okay, and then we'll write one final doc string here. We'll say, we need, yeah, given the data tuple returned by the get data via CID, search for a max absorption pattern, a quote max absorption pattern within the data string compound data text. Pattern within the compound data text within the data tuple provided, and we'll do data tuple index of 2. All right, cool. Sweet, so now we have a string, data tuple 2, we search over that, and so now we can simply call just these 3 functions of get the CID, get the data tuple, get the data of the CID, and then extract the ABS spectro, alcohol absorption spectro of that, and then if we run that, we get, get CID data. Oh, move that. There we go, and we've got our information here. So we've got the name is passed forward, the CID is also carried forward, the solvent, and lambda max and epsilon. Now instead, I mean, we could like have it just be one function, right? So we wouldn't have to pass the stuff forward. Or we could just have it be optional parameters and pass it in that way rather than being tuples. What do you guys think? That's a good idea. Turn the tuple into a dictionary and pass the dictionary through the flow. Ah, that's a good idea, because then at the end it's just a dictionary. That's good. I like that. Okay, let's do that. We'll do it quick. We got 5 more minutes. Okay, we can do it in 5 minutes. Okay, quick. So we're not going to return this. We're going to return a dictionary object where we have, quote, name is going to be name.lower, and and then the quote CID is going to be this guy. Okay, so then given the name of a compound for the returns a dictionary containing the name and CID of the name of the compound name provided, right? So now we get data via CD given, we're going to return a dictionary. And we're going to return a dictionary. And we're given a dictionary. Given the tuple, given the dict returned by getCID, search pubchem for the API compound within the dict provided. Okay, it returns a dict for compound name, compound CD, and compound data text. Okay, so then we're going to return dictionary here. we'll say that this is going to be compound dict. Okay, so then we're going to say, yeah, I like Python, Matty. Look what's going on, dude. Okay, so compound dict, we're going to add, this is the name. So we can return, what we can do is rather than creating a new dictionary in memory, what we can do is just return the original compound dict. This is going to be compound dict. CID. And then response here, return, we're going to go if response, we're going to turn this response to text, right? And so and then we're going to say compound dict index of compound data. Compound data string is equal to response dot text. Error 404. So if response, we're going to access the compound dict, pass in the string, and return, and then just return that, right? But we'll put a try here. There we go. So we'll try to do a response. Oh, I can't return this. I have to set this. And then return compound dict here. So then I'm going to do this outside of the accept there. Okay. So then what we'll do is we'll remove, this is a compound dict, given the data, the compound dict returned by the return, search for the max absorption pattern within the compound data text. Data string. Data to compound dict provided. Compound dict. Okay. So then I'm gonna say, what is this song? This song sucks. What is this? It's terrible. Ah, much better. Much better. Okay, so so we're going to compound dict compound data string. Oop. Right, equals to this. We're gonna search on that string. So I don't need to do this. I can just say this here, and then I'm going to take the compound dict so we're going to do if match compound dict solvent equals to this, compound dict lambda max equals to this, compound dict epsilon equals to this, and return. So then I want to remove, I need to delete, so I'll do compound, and then I'll do compound dict how do I go here and then do compound data string? I want to delete this. We don't need it anymore in this. So can I do like a del keyword? If I need to, can I say del compound data dict and then return that? So I had that earlier, Daniel. I had that earlier, but we refactor this way down rather than converting to JSON and then iterating over that JSON. I convert to a string and use a regular expression to find extreme. And we put it to the test, and it was almost 1,000 times faster doing it this way than converting to the entire overarching response into a JSON and then iterating over the keys and values in that JSON. And then finding the regular expression. So now I'm just doing it over a single string at once, and it was way faster this way. All right, let's try it here. Benzoic acid, CID, solvent, lambda, epsilon. Yes, we got it first try. Woo! Woo! Let's go. Some programmer, thank you for that suggestion of passing in the dictionary rather. That way we can, yeah, there probably are libraries, but I'm doing this from scratch to learn how to parse myself. Thanks for your input though. We're all right. All right, cool. Nice. Now we can save this into our local database, so we don't need to refetch it every time if a new user wants to search for benzoic acid, right? So the initial request might be a little bit long, but after that first request, once it's saved in our system, we can retain it there at least for a certain period of time pertaining to the allowance of the API itself. But yeah. Hey Samarath, what's going on, dude? We're building a spectroscopy simulator here, where we are, I've already wrote the algorithm for developing these Gaussian distribution curves given a lambda max and an epsilon, which is basically the wideness of the point. And so now what we did is we scraped using an API here, and then used a regular expression to extract out a pattern, and then we say saving these in a data structure of a dictionary. So we are getting appropriately each like fetch, we're extracting out all the information appropriately now from these calls. So if we type in here, let's type in like acetoacetic acid. Is that how you spell it? Oh, what did we get back here? We got something crazy back here. Interesting. What's it? Is it printing something? Is this what it returned in our object here? Interesting. So that gave us the benzoic acid, just like that, right? So if I type in like methylene blue, okay, we do have some bugs here we got to figure out. Shoot! What is this printing? What is this printing? Max absorption. All right, let's do, so yeah, this is printing here on our data tuple. So let's print, we get the CID, so let's print CID here. Oh. Okay, we're getting methylene blue, right? Oh, right. Okay, so in my other functions, I had things where if you didn't get these patterns, then you return an error, but I deleted those. So we have to figure out where those are getting hit now. Interesting. So 6099. So then if I print my data tuple, okay, so that's where it's all coming from. What is this? So this is my data tuple. So let's print data tuple given the CID. Let's print index of just the compound data string. Oh, we don't want that. Yeah, so that's what we're getting is the compound data string back. Interesting. Yeah, it's happening. So I think it's because I deleted those checks for no match taking place before. And so it's going into here and it's returning compound dictionary no matter what here. So I only want to return compound dictionary if you find a match. If no match, else raise, we're going to raise, I guess, value error, and we'll say, what do we want to say? No, UV viz data found. And we'll say error, or say error, no UV viz data found. And then we'll say for, we'll put into here, we'll put in the compound dict, we'll put in here the name. All right, so now this is a data, just for naming's sake, we'll change that. Data dict, so now we have that. Error, no UV viz compound. Perfect. So now what we can do is in this regular expression, so what we can actually do is if it's none, we'll return none. So we'll return the dictionary at all instances. We'll say else so no matter what, I'm going to delete the compound data string. Right, no matter what. But else, I'm going to go into here and go compound dict here. Well, maybe not. Here, I want to say is if the compound maybe you want to keep the value error. And then if you get a value error on using this function, you handle it. Okay. So we'll keep the value error, and then we'll keep the value error, and then when we call this function to do things in our backend, we'll handle this value error if it comes up. All right. Sweet. That was a good session. Anything else we should add here before we call it for today? Daniel, Semarath, Smatty Matty, Hugo, Tim, Civil. What do you guys think? Anything else we should add here before we kind of call it for tonight? What do you guys think? How we feeling? Bro, you've copy and pasted that 3 times, man. I'm not going to do that. What are you talking about? Are you saying like this? I'm just testing my functions. Like there's no point. I'm not going to run a loop here. And plus, I'm just setting up my program here for a backend, so there will be no loop. It's going to receive requests via API or via fast API. All right, you guys. I'm going to head out here tonight. I appreciate you guys being here. Please leave a thumbs up if you enjoyed your time here studying alongside me and Coden. We started off the stream by continuing on with our Calculus 1 journey, or Calculus 1 refresh rather. It's been 7 years since I'd taken Calculus 1, so we're retaking the course and using Python as our calculator to learn and perform various calculus functions and whatnot. So we completed our first quiz today, so it's awesome. But then how am I using the API? On requests when people request for it via front end. We're going to build, this is still the beginning stages of a function here. Yeah, we're web scraping here. So when someone types in a message and they press enter form, we'll run that, we'll extract that information out of the form, and then yeah, we're just testing, man. And the project's going to be a lot bigger than this. This is just setting up our actual functionality for. We already have the functionality for running the algorithm of developing the plots. Now we got the web scraping, and now we'll put it all together and link it to a front end and a back end, and then from here we're ready to go. So if a user types in a compound that doesn't have that UV viz data, we'll catch that error on the back end on that request, or that get request for that information from our server, and then we will say no, error or whatever. Yeah, I was wondering why you were spamming that over and over. It didn't make sense. All right, you guys, I appreciate you being here. Not yet. It's gonna be, so I've made some, we learned React. So I watched BroCode's React tutorial video, and we used that. We used that to make a portfolio website. So if you guys haven't seen that, go check that out. It's, let me show you here. michaeldeming.com. You can go see my portfolio, where I have my contractor position for Birdie Rose Close here, where we made on stream, right? Live on stream, we made Birdie Rose Close their entire business management system using Python and Tkinter. So we linked together a way to track inventory, expenses, sales, and then auto-generate using double entry accounting. My dad's a CPA, so I got his input, and an income statement and balance sheets pertaining to their business needs. And so it helped them a lot currently using it to run their whole, run and make money. So, and then I have my education here, and then a screenshot of my GitHub with some profile links, and about a blog section, some of my projects list. I need to make a demo video for this one, and then my community here. I also have another similar situation. So if you want to see something similar, oh, come on, what's going on here? Oh, it's got to just fetch my server. It hasn't been loaded up in a while. Might just take, hold on. No, I'm going to use React to build the front end. What's going on here? I think it's just render. When you use the free version of render to host, it takes a while. It might take a second to kick up your server, but why is this taking for that long? What is going on? Come on. Maybe I should change host to Vercel. Render is just too slow, dude. For my chroma plot. I've never had it take this long. Bro, this is brutal. Yeah, I think it's my spin up time here. All services are up and running. It says healthy. All right, it loaded up. Jeez Louise. All right, yeah, so this is my chromaplot.com, where you can put in various values and RF values or retention factors between 0 and 1 and name them, and then you can run basically simulations and download a GIF of these simulations where these compounds will travel up their medium through this mobile phase related to their retention factor. So yeah, it's pretty cool. Number one AI work to know. All right, you guys, I'm heading out tonight. Thank you guys so much for being here. I will see you tomorrow. I stream every single day around 7 p.m. PST after my 9 to 5 job as a formulation chemist. And so we appropriately today, did this. So it's really nice. Yeah. We got used our CIDs. We refactored this out, finished the regular expression pattern matching. And so if you type in a compound, let me give me some compounds from PubChem that have UV vis data. Let's see here. I think caffeine. Aha, we got it for caffeine. Vinyl, let's see. No UV data found here. Terapanthalide, what the heck? What the heck? Update not scriptable. Okay, so there's some. Obviously, it's not perfect yet with these. So caffeine works, benzoic acid works. Surprised methylene blue doesn't work. Oh, methylene blue. Spectral information. Okay, so they do have some other stuff here. It's just we need to maybe write some additional regular expressions to get potentially those other experiments, right? We're only getting that one experiment format, and some of these have some other formatting to them. Like if I look up, if I go aspirin, right? Aspirin will give us a compound here. If I go aspirin. No UV. Oh, never mind. I'm trolling. Where's my thing? Aspirin. Spectral information. Okay, so this has ether. Okay, so we might need to update our regular expression to get any values here. Okay. So let's update our regular expression here really quickly. Instead of hard coding alcohol here, we'll say dot plus. So now what happens if we run for aspirin? We get it. And we get the ether on the solvent. And then I want to make this be dot lower as well. Okay, so now we get where you have a universal solvent for that formatting of where we get the max. So now if I type in like methylene blue, do I get it here in ether? No, I don't have UV vis data. So, oh, I think I closed it. Methylene blue. Spectral information. Let's type in max. UV So we might need to set up like a regular expression for that potentially, or yeah. Cool. So there's some optimizations we can make to get even more information from this scrape, but awesome. I appreciate you guys being here. Let's go ahead and push this up, given this. Let's just make sure I didn't break it by typing in benzoic acid. One we know that works. There it is. Okay. So then let's go here and let's go git add, git commit. Add regex for parsing API response. Cool. All right, you guys, this has been fun. I really appreciate you being here. Please subscribe if you're new and like the stream if you had a good time hanging out with me, learning, just hanging out and studying. I'll see you guys tomorrow. Good job on the hard work, everybody. It's paying off here. We're really learning a lot, growing really rapidly, just in terms of our fluency, debugging skills, just ability to just code from scratch is improving rapidly. So thank you guys so much for being here, and I'll see you guys tomorrow. Bye, guys. Have a good night.